Hello friends, I welcome you in lecture number 38 on graph theory. In this lecture we are going to discuss about tree traversal. We will see how we can traverse the same tree by different tree traversal techniques or by different tree traversal algorithms. So before going for understanding tree traversal, first we require this definition of ordered rooted tree. What is ordered rooted tree? So the ordered rooted tree is a tree in which the children of each internal vertex have an order generally from left to right. If the children of each internal vertex has an order from left to right, then that type of rooted tree is called an ordered rooted tree. So we are discussing these tree traversal algorithms for ordered rooted tree. So we must understand this definition also. An ordered rooted tree is a tree in which the children of each internal vertex have an order. Now what is tree traversal algorithm? So tree traversal algorithm is a method for systematically visiting every vertex or node of an ordered rooted tree. The method of visiting every vertex of an ordered rooted tree and that visit is exactly one time or exactly once. That method is called tree traversal method or tree traversal algorithm. So remember, a tree traversal algorithm is a method for systematically visiting every node or vertex of an ordered rooted tree exactly once or only one time. So there are three different tree traversal algorithms which are most commonly used, and we are going to discuss them one by one. They are called pre-order tree traversal, in-order tree traversal, and post-order tree traversal. So we understand these three algorithms for tree traversal one by one. First we understand this algorithm pre-order traversal of a tree. So in this algorithm, first we will start by processing the root of given ordered rooted tree. After that we will consider the left subtree of root R in pre-order, and after that we will traverse the right subtree of root R in pre-order. So we can remember this algorithm in this way. First we are starting with root, say that we denote by symbol for our language, we consider RO for root. Then we are considering left subtree of root R. So for that we consider small l, capital L only, and after that we are traversing right subtree that we denote by capital R. So these three steps can be remembered in this way. RO means first we are processing the root R. Capital L means we are traversing the left subtree of R in pre-order, and after that we are traversing the right subtree of R in pre-order. So we understand with one ordered rooted tree this algorithm for pre-order tree traversal. So here I have taken this binary tree, and here I will find out, first I will find out pre-order traversal of this binary tree. So for pre-order traversal we are starting with root, then we are considering left subtree, and after that right subtree. So before starting, what we will do is we will write down this these three things, that is we are considering root that we denote by RO, then L that is left subtree, and then right subtree. So side by side of every node we will mention this. That will help us to easily find out the pre-order tree traversal of given rooted tree. So I am writing ROLR ROLR, ROLR, ROLR. For every node I am writing this ROLR. Root left subtree, right subtree, root left subtree, right subtree. Now in this pre-order tree traversal, we will start with root. First we will process the root and we will write down the pre-order traversal by considering all these steps. So first I am processing the root. So here root is A. So my first node in pre-order traversal is capital A. After considering this operation, I have processed root A. I am going towards the left subtree of A. So I will process or I will traverse the left subtree of A. So here I will cancel this capital L. That means I am processing to traverse the left subtree of this node A, and I will keep R as it is. Recently I am not traversing the right subtree of A. So because I am traversing the left subtree of root A, I cancel capital L here, and after processing in that direction to the left of A, I will reach to node B. Now here also first we have to process the root, so that is capital B here. Then so I am cancelling this root. Then I have to process again the left subtree of this root B. So I cancel this capital L and I am going towards the left of B. Now here root is before that, after cancelling capital L, I will check whether there is any no, I am going in right direction. After cancelling capital L, we will go to the left subtree of capital B, and here first we process root D. So I am writing root D here. After that we have to go towards the left subtree of D, but there is no left subtree here, so we cancel L. Now we are going towards the right subtree of D, so there is no right subtree of D also, so here I cancel capital R. Now we are going back in this direction. So after D we are going for B, and here we have to consider this operation, that is traverse the right subtree of root B. So here we cancel R and we are going to the right of B, and here we have to first process the root, that is I will cancel RO and here I will write capital E. After that I have to go to the left of E, so I am going in this direction, and here I will process the root F, so I cancel RO. Then I have to go to the left of F, but there is no left subtree of F. Similarly there is no right subtree of F. Now again I am going back. So here I have this operation pending, that is right subtree of E, but there is no right subtree of E, so I cancel here and I go back towards this direction and I come back to capital A. Now here what is pending? We have to traverse the right subtree of A. So we are going to the right side of A, and we cancel capital R. Now here we have to process the root, so I cancel this RO and here I write capital C. After that I have to go to the left of C, so I come here and then I have to process the root G, so I write G here. Then I have to go to the left of G, but there is no left subtree of G and there is no right subtree of G also. Now I am going back in this direction along which we have come up to G. We are going back in the same direction, reverse. And for this node C, this is pending, that is we have to traverse the right subtree of capital C. So we cancel R and we come back to this node capital H. Here we process H first, we cancel that arrow and we write H. Then next operation is left subtree of H, so we cancel this L and we go towards the left side of H, and here we have root J, so we process J, we cancel this, and then next one is left subtree of J, so we cancel this and we process in this direction. Here we process the root first, that is L here, then left subtree of capital L, there is no left subtree. Similarly, right subtree of capital L, there is no right subtree also. And then we go back in the reverse direction. Here for J, right subtree is pending, but there is no right subtree of J. Then for H, right subtree is pending, so I cancel R and I go in this direction. Here first I have to operate or process a root, that is K here, so I cancel this. Then there is no left subtree of K and there is no right subtree of K. And now we have seen that all the operations are performed. So this is our pre-order traversal for given rooted binary tree. So in this way we can consider pre-order traversal algorithm for traversing given ordered rooted tree. All we have to consider is that first we are processing the root, then we are considering left subtree of root, that is we will go to the left of that root, and after performing left subtree traversal we will consider right subtree traversal. And before traversing we can write this root left right for every node, so that we don't have any mistakes in writing the pre-order traversal. Okay, fine. So this is my pre-order traversal, and let me write it here. Here I am writing systematically. This is pre-order traversal for given binary tree, and I am writing this here, capital A, then B, D, E, F, C, G, capital H, J, L, K. Some authors consider comma also, and we can count the number of vertices here also, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Or we can consider this ABCD up to K. A, B, C, D, E, F, G, H. I is not there in our graph also. So we can count the number of nodes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let me count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So this is correct pre-order traversal. Now in a similar way we have two different algorithms known as in-order traversal and post-order traversal. Now we understand in-order traversal algorithm for the same binary tree. In this algorithm, first we will traverse the left subtree of given root R. Then we will process the root R, and after that we will consider right subtree of R. In pre-order traversal we are first processing the root, then left subtree and then right subtree. But in order traversal we are considering a root in between left and right subtree. So here in pre-order traversal we can remember that pre means first, so root comes first, and in order traversal we can consider in as middle or between the two left and right subtree. So we are putting a root between left and right. And similarly for post-order traversal, first we will traverse the left subtree, then right subtree, and then we will process the root. So now I will consider in-order traversal first for the same binary tree, and then I will perform post-order traversal. But we can remember in this way, for pre-order traversal we are first processing the root, then left subtree, and then right subtree. For in-order traversal, root is in between left and right subtree, and for post-order traversal, root is at the last. For pre, it is root is at the first position. For post order, root is at the last position, and for in order, root is in between left and right subtree. This L and R are always in this sequence, first left subtree and then right subtree, and by putting this root, by changing the position of root, we will obtain these three different tree traversal algorithms. For pre-order, we are considering root first. For in-order, root is in between these two, and for post-order, root is after left and right subtree. So now we can find out the in-order tree traversal for this same binary tree for which we have obtained in-order pre-order traversal. So let me remove all these things. Now instead of writing this ROLR, we have to write left subtree, then root, and then right subtree. And the procedure is same, but in order we have to first consider the traversal of left subtree, and then we will process the root, and then we will consider right subtree. So now things are different. Our algorithm is in-order traversal algorithm. So for in-order traversal algorithm, what we have to remember is that first we are processing left subtree, then root, and then we are traversing the right subtree. So for every node I am writing L RO R, left subtree root R, left subtree root R, left subtree root R, left subtree root R. Same thing I have to write for each and every vertex. It will not take much time. Let me finish this. And here also L RO capital R, L RO capital R. Now what we have to remember is we will consider this left subtree first, and then root, and then right subtree. And for every algorithm we will start with the root of given binary tree. So here A is the root, and for this I have to first traverse the left subtree of A. So I am cancelling capital L and I am traversing to the left of A. After that, for this subtree B is the root, so I will consider first operation is left of B. So I am going in this direction. Here also first operation is left of D, but there is no left subtree of D. So second operation is process the root. So we are first writing capital D for our in-order traversal. So I cancel this arrow for capital D, and then next operation is right subtree of D. So I cancel R, there is no right subtree of D. Now we are going back in the same direction along which we have come from A to D. So we go back and we see that now for this vertex B we have to perform this operation root. So we are writing capital B here. Then we have to consider traversal of right subtree to the B. That is, we have to go to the right of B. let me write here. Here I have to write L R O R. Now here also first operation is capital L, that is we cancel it and we go to the left of E. Here also we cancel capital L and we check whether there is any left subtree of capital F or not. There is no left subtree as well as right subtree. So next operation is process the root. So here we write capital F and there is no right subtree, so we cancel this. Now we go back again in this direction, reverse. So here pending operations are root, that is we cancel this and we write capital E, and there is no right subtree of E, so we cancel this also and we go back in this direction. Here pending operation is process the root, so we cancel this and we write root A. Then we have to go to the right of capital A. Here first operation is capital L, so we cancel L and we go to the left of C. Here also we cancel L and we go to the left of G, but there is no left subtree. Then next operation is root, so we process the root G. Then there is no right subtree, so we cancel R and we go back in the reverse direction. We come at this vertex C and here pending operation is root operation, so we write C and we cancel root. Then we traverse to the right of C, we cancel R and we traverse to the right of C. Now here for vertex H, first we have to process capital L, that is to the left of L. For J we have to process capital L first, that is we go back in the left of J. Here also we cancel capital L, then there is no left subtree of capital L. Now we cancel, process this root L and we cancel this, we write L here, and there is no right subtree of L, so we cancel this also. Then we go back in the reverse direction. Here pending operation is root, that is we have to write G. Then right subtree of J, there is no right subtree here, so we cancel R and we go back in this direction, reverse. Here operation is root, so we cancel root and we write capital H, and then we go to the right of H. Here first operation is L, there is no left subtree of K. Then second operation is capital K, we cancel this and we write capital K, and then there is no right subtree of K. So now we can count this number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So this is our in-order traversal. So that we can write here in-order traversal. In-order traversal for this binary tree is dbfea. Let me write here dbfe capital A, dbf capital E, dbfea, gclj, and I think H and K, gclj, H and K. Okay, fine. So this is the in-order traversal, and now finally we find out post-order traversal. For post-order traversal, first we have to consider left subtree, then right subtree, and after that we have to consider or process the root. So what we have to remember for post-order traversal is left, right and root. For pre-order traversal, we are first processing root. So we remember for pre-order, we remember that root, left and right. For in-order, we remember left, root and right. And for post-order, we remember left, right and root. So now finally we are considering this post order. So for post order, first we are considering left, right and then root. So let me write left, right, root for every node. Left, right, root, left, right, root, left, right, root. Similarly, let me finish all these things. So you can see this is very easy process, and all you have to remember is that how this algorithm is working, and it is easy to remember. We have to remember left and right in a sequence. For pre-order, root is first. For in-order, root is in between left and right. And for post-order, root is at the last position. Now we are writing the post-order traversal, and every time we will start with the root of given tree. Here root is capital A, so I will start with capital A. First operation is I have to go to the left of root A, so I cancel capital L and I am going in this left subtree of capital A. Here first operation is L, so here also I will go to the left of B. Here first operation is capital L, but there is no left subtree of D, so I will process for capital R, but here there is no right subtree of D. And next operation is root, so our post order traversal start with capital D. Now we go back in the same direction. Here we come to vertex B. Here we have to perform or traverse the right subtree of B. R means we have to go in the right direction of B. So we cancel R and we go to the right of B. Here first we have to consider left of E. So we cancel L and we go to the left of E. Here also we have to go to the left of F, but there is no left subtree. Then we have to go to the right of F. There is no right subtree. So we process capital F. Root means we have to write that root in our traversal, and then we come back in the same direction. Here we have R means right of E, but there is no right subtree of E, and then we process root E. So next I am writing capital E. Now I am going back. Here root is pending, so I cancel this and I am writing capital B. Again I am going back to the root capital A. Here I have to perform right of A, so I am going in this direction. Then left of C, I cancel this and I go to the right of A. Here first operation is L, so I cancel L and I go to the left of C. Here first operation is capital L, but there is no left subtree of G. Similarly there is no right subtree of G, and then we process root G. So we write G here and we go back in this direction. Here we have R, that is we should go in the right of C. So we are going in this direction, and then we should go in the left of capital H. So I cancel L and I go in the left of H. Here also I cancel L and I go in the left of J. Here also I cancel L and I can see that there is no left subtree. Similarly there is no right subtree, so I have to process the root L. Now I am going in this direction backward. Capital R means right subtree, but there is no right subtree of J, so I have to process the root J. Then I come here. Here capital R means I have to go to the right of H, and here capital L means I have to go to the left of K, but there is no left subtree of K, so I cancel L. Similarly there is no right subtree of K, so I cancel R and then I process the root K. Now I go back in this direction. Here pending operation is root, so we process the root capital H. then we go back in this direction. Here pending operation is root, so we process root C, and then in this direction pending operation is root, so we process the root capital A, and we can count the number of vertices 1 2 3 4 5 6 7 8 9 10 and 11. So this is our pre-order traversal for the same, not pre-order, it is post-order traversal. So let me write post-order traversal which we have obtained here using the post-order traversal algorithm. Post-order traversal which we have obtained, that I am writing directly. I have this df capital E capital B G capital L J K H C and A. Let me check here also. D F E B G D F E B G L J K H C A L J K H C A. So this is the post order traversal of given binary tree. So it is very easy to write down this tree traversals using this tree traversal algorithms. Now you can see that all these three algorithms are consuming much time, but we are having another shortcut method also for writing all these three traversals: pre-order, in-order and post-order traversals. So now I am discussing that short technique for writing all these pre-order, in-order and post-order traversals. So for that I am considering this type of arrows here. I am considering 3 arrows for each node. This is for in-order, this is for post-order, this is for pre-order, this is for in-order and this is for post-order. So I will explain you why I am considering this type of lines here for every node. That will help us to write down these traversals for this tree. This is for pre-order, in-order, post-order, pre-order, in-order, post-order, pre-in and post-order, pre-in and post-order. Now what is this short method is that we have to consider a closed curve starting with vertex A and ending with vertex A. That is, we will start that curve, closed curve, which will traverse all the vertices in this way. And while doing or while traversing this tree along that closed curve, what we will remember is that when closed curve touches this line, then we will write down vertex A in pre-order. When closed curve touches this line, we will write vertex A in order, and when closed curve touches this line, we will write vertex A in post order. So we are simultaneously writing all the tree traversals, pre, post and in order traversals. So let me write for pre, I am writing shortly. This is for pre-order traversal, this is for in-order traversal, and here we will write post-order traversal. So again I repeat, what we are going to do is we will start with vertex A. We will consider closed curve starting with vertex A, and it will go through all the nodes and we will come back to this vertex A. Now while traversing all the nodes through that closed curve, whenever closed curve touches this line, that is line to the left of given node, we will write down that corresponding node in pre-order. Whenever closed curve touches this line, we will write down that vertex in order, and whenever closed curve touches this line, we will write down that vertex in post order. So now we process with this vertex A. So if I start with A, I can see that this line touches this closed curve touches this line, so that is for pre-order. So I am writing capital A here. Then I am traversing, and here we can see again I have to write capital B because it touches the line of pre-order. Then for D, again I have to write D in pre-order because this closed curve touches the line of pre-order for vertex D. Now we will go in this direction. So here it touches this line, and this line for D is for in order. So I will write D for in order. After that I will go in this direction, and we can see this curve touches the line for post order, and corresponding vertex is capital D. So we will write capital D in post order also. Now we are going in this direction. So we can see for vertex B line is in order. So I am writing vertex B in order. Now I am going in this direction. So this line is for pre-order for vertex E. Therefore I am writing capital E in pre-order, and I will continue in this way. For F, this line is for pre-order, this line is for in order. So I will write F here also, and it touches the line for post order also. So I will write capital F here also. Then I am going in this direction. For E, this line is in order, so I write E here, and I have to go in this direction. So we can see capital E is in pre-order also because of this line. Now I traverse in this way. So this line is for post order for vertex B. So I am writing B here. Then for A, this line is in order. Then I am going in this direction. For C, this is pre-order, and here for G also this is pre-order. Then for G, this is in order. For G, this line is post order. For C, this line is in order. For H, this line is for pre-order. For J also it is touching the pre-order line. For L also it is touching the pre-order line. And again if we go in this way, for L it is in order. For L it is post order also. For J it is in order, and for J it touches the pre-order line. So I write J here also. Then for H, it touches the line of in order. So I write H here. For K, it touches the line for pre-order. Then it touches the line for in order for K again. And K is in post order also because this is the line for post order. And for H, this line is for post order. For C also this is for post order. And for A also this is touching the post order line, and we finish this curve. So we started by considering this closed curve starting with root A, and by considering this type of closed curve traversal, and what we have taken care is that whenever closed curve touches this line, this vertex is in pre-order. Whenever closed curve touches this line, this vertex is in order, and whenever closed curve touches this line, this vertex is written is post order. So this is another shortcut technique for writing the pre-order, in-order and post-order traversal of a given binary tree. Now we can compare this both the answers, they must be same. if we have done all the things correctly. We can compare the pre-order traversal. Here I have A, B, D, E, F. Let me check here. Here also I have A, B, D, E, F. Then C, G, H, or we can minimize this. We can check our answers. So you can see here I have C, G, H, C, G, H, J, L, K. And now we compare in order also. Here I have D, B, F, E, A. D, B, F, E, A. G, C, L, J, H, K. G, C, L, J, H, K. Then D, F, E, B. Then G, L, J, and K, H, C, A. So this is very easy shortcut method for finding these three tree traversal algorithms. So either you can use earlier method which we have discussed one by one, or you can consider this type of closed curve traversal, and you can remember that whenever I am touching this line, suppose vertex is R, if my closed curve is touching this line, I will write vertex R in pre-order traversal. Whenever closed curve is touching this line, I will write capital R in in-order traversal, and whenever closed curve is touching this line, I will write capital R in post-order traversal. So in this way we can find out pre-order, in-order and post-order traversal of a given rooted tree. So I have tried by best to explain all these three algorithms. If you have any queries, you can ask in comment section. Thanks for watching.